Hello, Algebra 1 students. This is our Interim 3 review with Mrs. Limbrick. So we're starting on number 1. We are looking at the greatest common monomial factor. So it's really the GCF. In Desmos, remember you can do GCF and put in 15, -10, and 20. And then Desmos will tell you that the GCF of those numbers is 5. Then we look at x to the 5th, x cubed, x squared. The smallest is the 2. So we also have 5x squared. So the factored form will have the 5x squared to the side. And then in parentheses, we go back and we divide each one by 5x squared. And then in our parentheses, we have 3x cubed minus 2x plus 4. Let's look at the next one. We this time have 39, -24, and 3. So again, use Desmos to find your GCF, and you should get 3. Then we look at the m's, and the smallest is m cubed. And we look at the n's, and the smallest is n squared. We write it to the side, m cubed, n squared, and then in parentheses, after we go back and divide all of these by 3m cubed, n squared, we get 13 m to the 4th minus 8n squared plus 1. So don't forget the plus 1. And then on our next one, we test out our numbers once again, and the GCF is 4. And from the variables, we get x squared and y squared. We write that down as our GCF to the side. We divide all of these by 4x squared, y squared, and we end up with 4x squared plus 3y minus 2y squared. Moving on, factor completely. We always ask ourselves, is there a GCF? And we look at this, and definitely not. We only have a 1 up in front here. So we say, all right, a equals 1, b equals 6, c equals 5. A times c is 1 times 5, which is 5. We're looking for 2 factors of 5 that will add up to 6, and right away, 1 times 5 will add up to 6. Now remember, because a is 1, I do not need to make the box. I can go straight to x plus 1 times x plus 5, and I'm done. Now if you check with Desmos, remember that in Desmos, it's going to cross at -1 and -5, which corresponds with changing the sign here and here for the factors. For B, again, is there a GCF? No. So we go about doing our A equals 12, B equals -11, C equals 2. A times C will give us 24. And we need 2 numbers that multiply to 24. So it could be 1 and 24, or negative of both of those. 2 and 12, or negative. 3 and 8, or negative. And I see it right there. Okay, so I don't even need to move on to the 6. I stop, and I see those 2. So remember, you are taking this and you are splitting it 12x squared minus 8x minus 3x plus 2. So to put it in the box, we do this, and we put 12x squared here, and we could put our minus 8x minus 3x plus 2, and we go about looking for GCF. So 12 and 8, it will be 4, and with the x's, it will be x. Now these have nothing in common, and this is negative in the front, so we will say -1. Looking at these two, +3, because this is positive, and x, and these both will have a negative 2. So our factored form is 3x minus 2 times 4x minus 1. And of course, you can check in Desmos by putting the original in line 1, put your answer in line 2. They should match. Again, do we have a GCF? We do not. So we do A equals 4, B equals 12, C equals 9. And we multiply A times C, and it gives us 36. 1 times 36, or negatives. But as you can see, this is a positive 12, so I really don't need the negatives on this one. Then we can move on, because that's not going to give us 12. 2 times 18, 3 times 12, 4 times 9. Still not there. How about 6 times 6? There it is. They are the same. So we will separate this into 4x squared plus 6x plus 6x plus 9 and make our box. Let's put our 4x squared and our 6x, and then the 6x and the 9, and go across. 4 and 6, we get 2x. 6 and 9, we get a positive 3. 4 and 6, once again, we get 2x. And 6 and 9, once again, we get a positive 3. So this factorization is actually 2 of the same thing. 2x plus 3 times 2x plus 3. Or it could actually be written as 2x plus 3 squared. That would also be correct. Number or letter D. Do they have a GCF? Yes, they do. We can divide them all by 2. So I write down the 2 and divide each one by 2, and I have 2x squared plus x minus 6. So once again, I need to go through my process. A times C is negative 12. I have negative 1 and 12, or positive 1 and negative 12. I have negative 2 and 6, or positive 2 and negative 6. Negative 3 and 4, positive 3 and negative 4. And I think we found our 1 that we need right here. So we have our GCF. And now we write out 2x squared. Instead of the 1, we're going to use negative 3x plus 4x, and then minus 6. We're going to take it to the box and put in 2x squared minus 3x plus 4x minus 6. Going across here, only x. Here, positive 2. Up and down, 2x. This vertical, negative 3. So our factors are 2x minus 3 times x plus 2. E, is there a GCF? Well, yes, there is. Do you see it? The GCF is 3, between the 3 and the 12. And then when I divide each of those by that 3, I end up with x squared minus 4. Now, if you want to, you can turn it into x squared plus 0x minus 4 if you want to use the a and the c. But if you recall, when I have two terms with subtraction, I might have the special difference of squares. And in this case, I do. The square root of x squared is x. So I put an x here and here. The square root of 4 is 2. So I put a 2 here and here. And then one of them has to be plus and one of them has to be minus. And I'm done. But make sure you have that 3 included. Part F, letter F. Is there a GCF between 12 and negative 27? Yes, there is. It is 3. and I set up my parentheses. Let's divide each of those by 3. 4x squared minus 9. Well, once again, if you wanted to, you could put a 0 in there and then go about your factoring. But we do have a difference. So let's see if we have perfect squares. The square root of 4x squared is 2x. So yes, we do have a perfect square there. And we know the square root of 9 is 3. So we do 3 and 3. And then, like we said before, we need 1 plus, minus, doesn't matter which one. And there it is. All right, moving on to simplifying the expressions. Well, this is just like what we did with our GCF up here or even over here. We get to take this and really divide each piece by that monomial. So let's do each one. This is going to give me negative 4x to the 5th because it's 7 minus 2. This negative 6 over 6 will become negative 1, and then 4 minus 2 is x to the 4th. Now remember, you actually don't need to put the negative 1, and this is how you would see it as a final answer. And our last one, 12 divided by 6 is 2, and then our 3 minus our 2 is just x. So that is our result there. Let's do the same thing on part B. Let's divide each one by 3y. 18 divided by 3 is 6. 4 minus 1 is 3. Negative 9 divided by 3 is negative 3. 2 minus 1 is just 1. Now right here, be careful. When it matches exactly, you still need to put a 1, something divided by itself, to hold that place. That ends page 1. I'm going to stop the video here, and then I'll start page 2 on the next one.